So here we'll be looking at one of the hardest questions in the topic HCF and LCM. So the question is that how many pairs of integers x, y exist such that the product of x, y and the HCF of x and y is 1080. So take your time, give it a shot, and if you don't get it, then look at the solution. Okay, so the correct answer here is C, 9. So there are not 9 ordered pairs, there are 9 pairs of integers x and y such that this condition is satisfied. So the condition given here is that the product of x, y and the HCF of x, y is 1080. Let HCF be h. So we are given that x into y into h is equal to 1080. Now, as h is a highest common factor of both x and y, h has to be a factor of each of x and y. So let x be h into a, some integer a, or y be h into b for some integer b. And note that as h is the highest common factor, a and b cannot have any common factors. So that is to say that a, b are co-prime. That is that they don't have any common factors between them. Okay. So now just putting the values of x and y in terms of h in this equation, we get h cube into a into b is equal to 1080. Okay, so we'll now just try to factorize 1080. This can be factorized as 2 into, that's 540 into 2, we are left with 270 into 2, we are left with 135, so we take 5, so then we are left with 27, which is actually 3 cube. So this could be written as 2 cube into 3 cube into 5. So now we have to consider cases for the highest common factor. Let the highest common factor be 1. So if h is equal to 1, then AB has to be equal to 2 cube, 3 cube into 5. Now, in how many ways is this possible? So A and B, remember A and B are co-primes, so they cannot have any common factor between them. So if we are taking 2 cube, it has to come totally in either of A or B. It cannot happen that we are taking 4 in A and 2 in B. So let's take it in A, suppose 2 cube. Similarly with 3 cube, let's again take it in A. So we are taking this as A right now, and take again A, if take 5 also in A. So we get the whole 1080 thing inside A, and B is 1. Okay. So now the second case could be A is equal to 2 cube into 3 cube, and B is 5. Similarly, we can take other cases, 2 cube into 5, and B could be 3 cube. Similarly, we can take A equal to 3 cube into 5, and B could be 2 cube. Note that these A and B could be like reversed also. We are not taking ordered pairs here. So we'll see that these are the only 4 possible ways like this can happen. So we'll just write the number of pairs here to keep a count. Okay. So initially we took h as equal to 1. What other values can h take here? Comparing these two sides, we need a cube on h. So h could be either 2 or 3. So taking, it can be either 2 or 3 or even 6, because we have a 6 cube if we combine these two. So we have 3 more cases left. So let's first take h equal to 2. So we will be left with a into b equal to 3 cube into 5. Now this can happen like if we take A equal to 3Q into 5 and B equal to 1, or A equal to 3Q and B equal to 5. Okay, so another way this could happen is that we take A equal to 5 and B equal to 3Q. But note that these two are the same, so we cannot actually differentiate this case. We are not taking ordered pairs. A and B could be exchanged with each other. So there are only two ways actually to, to have the values of A and B here. So the third case is H equal to 3. Now this is very similar to the case above, just replacing like 2 with 3 here. So basically we'll again get two cases here. We don't have to again solve it for the whole thing. So now the last case is H equal to 6. Here we had AB. We'll be left with AB equal to 5. This can happen only in one way. Like A is 5 and B is 1. And of course these can be interchanged, but we are not taking ordered pairs. So we have one case. So total, now we had 4 cases here, 2 cases here, 2 cases here, 1 here. So total we have 9. So 9 is the correct answer.